So you should add. Yeah. 15:55 probably, because we need 5 minutes more to prepare the next speaker. Probably.
Okay. It's basically 45 minutes for the presentation itself, and then there is 10 minutes for the question.
Okay.
We will show you the signs.
That's fine. That's fine.
Whenever you're ready, you can start.
So, hi everyone, thanks for coming. I'm Rafael, I'm software engineer at Red Hat. I work here in Brno office. I am a member of the Overt integration team. Among other things, we basically handle the Overt releases and the Overt installers and so forth. And the main goal of this talk is to show how we use Lago in our project and how it can be used by other virtualization projects to improve the development and testing and stuff. So I'll start by describing the problem. The main problem is that virtualization products are usually big. They have usually lots of integration with other stuff, like with different storages, different authentication backends, networking and stuff. And when you need to test a patch or find a bug or something like that, sometimes it's hard to reproduce the environment you need to reproduce the bug or to verify if the patch is correct. Lots of people like to use snapshots to reproduce VMs and stuff, but sometimes the bugs are too specific to some specific use case, and it's not possible to just rely on snapshots. And setup usually takes time. For example, to get Overt up and running from scratch, you need to set up lots of VMs and integrate all of them together. And you usually spend a lot of time doing that, so it's something that should be automated. Other than that, the release manager also needs some automated tests to make sure that code is ready to be released. For example, in Overt, we basically do at least one release per week. So having automated tests to make sure that nothing got broken in the meantime is needed, because having manual tests every week sometimes is not really possible. So we need to have to make sure that at least the basics are working fine before we do a new release, even if it's just a release candidate or a not really stable release. So I use Overt as a use case for Lago. That is the main topic of the presentation. How many people here knows Overt or Rev or something similar? Nice, lots of people. So basically, Overt is an application to manage a virtual data center or multiple virtual data centers using remote network storage like NFS, iSCSI, and Gluster, and similar. And it's powered by KVM. That is a technology that most people use to use on Linux. So it's something that should not be new for people. It also supports several authentication backends like LDAP, and internal authentication and integration with Active Directory and others. This is a screenshot of the dashboard of one of our internal instances of Overt. You can see that it's quite large deployment. Not really large, but it's not something usual. We have 3 data centers and stuff, lots of memory, lots of VMs, hosts. And this is how the Overt engine looks like in the browser. So the solution we found for improving the testing and development was the Lago project. And that is a virtual framework that helps you create the environments and create virtual machines and stuff. So you can automate that deployment that I said in start that was hard to do. It's based on libvirt and KVM, and it can. The good thing is that Lago is not really tied to ovirt. I'll talk more about that, but with our Python API for plugins, most of the functionality is implemented as plugin. For example, even the libvirt support to create VMs is a plugin on Lago. So you can potentially write a plugin to start VMs using some other backend. So this is how we use Lago for ovirt. We implemented the ovirt Lago plugin that is what does all the integration with ovirt services and start ovirt related stuff. And Lago just manages the virtual machines and makes sure that everything works. But all the ovirt related job is done by ovirt Lago plugin. For example, the plugin can repo sync RPMs for do some caching to be used by VMs. It will also create a local repository that is used by the VMs to speed up installation and stuff. And we have plugins we have some test libs to help implementing engine-related stuff like calling the API, like collecting logs and stuff like that. So we can say that Lago is totally isolated from ovirt Lago, and you can take Lago and make it support any other product you want without too much difficulty. So to solve the problem of the automated tests, we have the ovirt system tests. That is basically a big test suite that will test the main flows we have for ovirt. It's run in Jenkins, and we have some basic setups like creating some engine hosts and integrating them, adding storage, adding configuring network, and creating VMs and make sure that it all works. So we have Lago managing all of that, and the environment being tested. It is very good because with the system we have a really quick visibility of breakages. If some patch just broke the integration of the system and something is really bad, we will fastly know about that. And through Jenkins. And the good thing is that as the visibility is very big, we have most people looking at it and improving the test cases because we quickly realized that it was useful to maintain it as updated as possible. But on the other hand, we can't properly cover most corner cases on this test suite because, well, it's a big product with lots of moving parts. It would not be possible to cover everything. And as a side effect, the virtual machines are not destroyed automatically after the execution. This is useful for manual testing. That is what I will introduce later. So this is our Jenkins instance. I got it on a day that it was not really nice, but it's a good example. It shows we have tests for most of our supported versions, 3.6, 4.0, and 4.1. We don't really support. We are not really doing 3.6 releases at this point, but it's still tested. And it's easy to see if something is broken, when it broke, and for how many days it's broken, and to see the logs and see what's the issue and stuff. So it's really nice. Now about manual testing. As I told before, the ovirt system tests won't destroy the VMs after execution. So if you want to test something and have the environment ready and the ovirt system test environment is good for you, you can just run the test suite, and when it's done, you just access the VMs and do your job there without any issues. We have our Jenkins instance can build RPMs from Jared patches. We use Jared to manage our development. And with those RPMs, you can just ask Overt System Tests and Lago to build VMs using custom RPMs. This way, you can test your patch without having to set up everything by hand. And developers can also build it on local machines, but it's easier to use the Jenkins because they are all integrated already. And you don't need to set up local environment to build RPMs. But there are downsides on using the system test for that are you need to run the system test every time, and this takes time. The test suite is extensive. So and if the patch you are working on changes the behavior, like for example, if I am writing a test for the setup script and I added a new option on the process, it will break the test. And I'll need to go there and update the test. This is not really a bad thing. This is a good thing because this makes developers that are implementing changes that will change behavior look at the system test and update it beforehand. So it's really using system tests for this case is really a benefit because it helps keeping the tests updated. But it will take time. If you need to do some iterations on testing, it will take a lot of time to run the tests every time and stuff. So this is not always handy. So I will give this as an example of how you can use Lago to integrate with stuff by writing plugins. To solve this problem of having to run the tests every time, we created a plugin that just creates the environment without running the tests, and you can have the environment faster. And for example, the system tests will always create the same VMs. Most of the tests will create one engine and two hosts, or one engine and one host. Sometimes you need more hosts. Sometimes you need a more specific setup, and it's not possible to do with the system tests without editing JSON and stuff. So we created this thing that is a command line where you have a declarative way to say that we want two engines and two hosts and memory and stuff. This is all based on Lago. And we use Overt Lago to interact with Overt. It could be some other plugin to interact with other service if it existed. And it uses Lago API to create some stuff. And it also have the benefit that it will give you the environment ready to use. It will create NFS if you want, iSCSI if you want, and will attach the host to the engine. So you can create any kind of automation for testing you want using Lago. Here I added some usage examples. The first one is a deploy. It basically creates an engine and two hosts using some RPMs that were generated by Jenkins. And we have a very simple syntax to define the VM properties, the name, memory. There are other parameters. You can define the distribution to, for example, use Fedora instead of CentOS. And it's very flexible, and you can create as many hosts you want, and they will be attached. We have another command that is engine setup. This command will automatically configure and connect the hosts to the engine, but sometimes you don't want it. Sometimes you want to configure everything manually. In this case, you just connect using Lago to the engine machine and run engine setup by hand and do whatever you want. But at this point, you just have everything handy. So yeah, it's very easy than configuring anything by hand. I have a small demo I want to show you of this working. Okay, so this is the command I will run. It will create an engine with default parameters that is 4 gigabytes of memory, and we create 2 hosts with 1 gigabyte of memory each one. I cut some parts of the demo to be faster, but it's creating network, bootstrapping VMs and stuff. Creating VMs, saving VMs, creating network. It will get everything ready for you. And now deploying the engine and the 2 hosts I asked for. We have those steps are defined as this deployed Overt environment, for example. They are all defined on the Overt Lago plugin. They are not defined in Lago. So you could have the exact same tasks for example, OpenStack or something else, if that's the case. So everything is deployed. The next step is to set up the engine. This is again done by the Overt Lago plugin, but it can be extended. It copied the answer file from the VM and run engine setup. After that, it's configuring the host. That means adding the host to the engine. And after that, it will add the storages to the engine as well. So engine setup took like 3 minutes. And I forgot to show before, but the deploy of the VM took like 5 minutes. And after that, we will have the engine running the browser right away. The certificate is self-signed, so it needs to be accepted. So after like 10 minutes, you have engine running with your custom patches, and the host is being installed right away as you wanted, and you are ready to test your patch and see if everything is okay. I can say that as I work on the setup scripts, sometimes I even spent the full day trying to reproduce an environment and to build an environment to test. So this is really handy. So, but there are also some downsides on this approach. To make things automated, we don't do the same that Lago does by default. We want cache the RPMs from the repositories and make a local repository to be used by the VMs, because sometimes we want to use different distros. We need to test at the same time with Fedora, with CentOS, and we need to. The thing is that in Overt system test, we have a big definition of the repositories that is manually written, and so we can, for example, we don't need to fetch all of EPEL and cache all of EPEL. This saves a lot of space. When we are doing everything automated, we are just downloading the release RPM from the mirrors and installing it. It's not possible to benefit of that because it needs manually maintainership. So we have this downside that it will always download everything. So this is something that I think that can be improved, but yeah, it works. It's already way better than what we had in the past. So at least for me, it's not a big concern. And right now, we can deploy more than one engine, at least if you want to use the automated engine setup, because it won't know to which engine attach each host. It's just for that. But if you don't want to use automated setup, if you want to set up it manually, you can deploy as many engines as you want. Another thing to say is that Lago, the plugin, knows if a VM is an engine or a host. We implemented this way because it's important to test to know if a VM is an engine or a host. But Lago itself doesn't know that. For Lago, they are all VMs, but for Lago, they are different. They are handled differently. So, as I'm telling all of this talk, Lago is not tied to any product, even Overt. So we can use it for whatever you want. To test virtualization manager, something similar to Overt. To test appliances. Or even if you just want to build a VM environment to do some work, or that's not really related to a virtualization product, but you need like lots of VMs and have them in the same network easily, you can just use Lago for that as well. This last one can be done even without plugins if you don't want to. Also, there's a question that is frequent, that is why we should use Lago instead of some other well-known solutions in the market. The first case, the most obvious case is Vagrant, that is a very popular tool. Most people like to use it because it's really easy. You can have definitions of VMs in a Git repository and just call Vagrant app and have it working. But the thing is that, at least from a point of view, Vagrant is more targeted at development. Like, you need a VM to help you write your code, not really to run your code. It's not really, I think it's a different phase of the process. I see it being used more like to create the development environment instead of the testing environment, I would say like that. But it is still a good alternative. And actually, it is possible to write a Lago plugin to use Vagrant as the provisioner of VMs. I don't know if someone is working on that. I heard about it some time ago, but I'm not sure. And yeah, as you can change the provisioner, it would be possible to use Vagrant as well, generate the definition and just build the VMs with Vagrant. Some people also asked about Avocado. Amador is here. He did talk about it yesterday. Well, it's different thing. Avocado is more a test runner. It not really builds the environment. At Lago, we have our own test runner that is based on a unit test, on Python unit test. But it would be possible it would also be possible to write a Lago plugin to run tests using Avocado instead of using our internal test runner. Actually, to be more specific, the test runner we use today is not even part of Lago. It is implemented on your virtualago plugin. So basically, you are free to do whatever you want. If you are, for example, implementing a plugin for OpenStack, you would be able to just start using Avocado for testing, if it was what you want. And as a last example, there is Lava. I don't know if a lot of people know it. I worked with it in past. It is from Linaro. It's Linaro Automated Validation Architecture or something like that. It is very similar to Lago, actually. But it is targeted at running tests on devices, on ARM devices or Intel devices. It was not really designed to run tests on virtual machines, but the design and the architecture are kind of similar to Lago, but it is for real devices, not really virtual machines. Oops. Yeah, that's it. If you have any questions, if you want to ask something, or say that I thought something wrong, it's your opportunity.
I have a question.
Yeah.
Does Lago support fencing, so like testing high availability?
Out of the box, no. Out of the box, no. You need to implement that.
Like in the VMs, you can test that as well, because it's one of the parts of it.
Yeah, it's possible to do, but I think it needs some code. Not really hard, but I think it needs some code. Anything else?
I think so. Lago supported outside of Fedora RPM-based systems. I heard that it's being ported to Debian, but I'm not sure how far this effort
Okay. Basically, Lago itself can run on almost any system that have libvirt, as it is now. There is work to port to Debian. I'm Gentoo developer. I'm writing an overlay to run Lago on Gentoo because I want to use it there. But the virtual machines. The question. He asked if there are plans to support other distributions in Lago, other than the Red Hat supported distributions. Yes, there's someone working on Debian, and I'm working on Gentoo. Out of the work, it's not really part of my job, but I want to use it. And Lago itself can run mostly anywhere. You have libvirt. You may have some issues if you have something different from SE Linux. If you use something like AppArmor, you need to do some manual configuration, maybe. But it is possible to run. The thing is that most of the code we have today will deploy systems on CentOS and Fedora, RPM-based distributions, basically. So, for example, if you want to do some testing using DABs, you need to write a plugin for that. But it's totally possible. We are not tied to Fedora or CentOS or RHEL. More questions?
So, if I understood this correctly, you are using nested virtualization to set up your environment, right?
Yeah.
So I wonder, how do you include the possibility that nested virtualization doesn't interfere with your testing? Or how can you be sure, in other words, to that it doesn't harm your testing?
He asked how we make sure that that obviously we use nested virtualization to run VMs inside VMs that create VMs. It's something like an inception. And how we make sure that this does not affect our test results. Basically, we don't have way to make sure of that. I'm not aware of anything in that way. But for hardware restrictions and stuff, almost all developers of Overt and of other services are using nested virtualization. So I would say that running Overt, at least for developers, with nested virtualization is a more common case than running on bare metal. So yeah, there's no way to. I think that there's no way to even detect that we are running on nested virtualization and not on bare metal from Overt. So yeah, I don't know if we don't have a way to detect that, but I don't think that it affects the results in the end. More questions? So thank you. Here you have my contact, and you feel free to reach me out. We also have, I forgot to put it here, but we also have a Lago channel on Freenode. It's called Lago. You can just go there and talk to us. Thanks.